In the previous video in this series, we discussed the purpose of the parallel chart and showed how parameters and design points are displayed on the chart. In part 2, we'll continue with our scenario and manipulate the chart to find promising designs for our product. The parallel chart enables us to view all dimensions of our analysis at once, so we can see at a glance how any given design point responds to different combinations of inputs. When you have many parameters to investigate or many designs to choose from, the parallel chart allows you to plot them all at once and compare them more easily. We can use the chart's display, sorting, and filtering capabilities to select a subset of feasible design points for exploration and to ensure that only relevant data is shown. For example, we can use the chart to discover the variation range of the output parameters. Here, we can easily see the minimum and maximum values of the outputs. We can determine which design points produced the min and max values and select them. In this case, we can see that DP4 is responsible for both the output minimums, and DP10 is responsible for both output maximums. We can also see that most of the intermediate design points fall between the current design point and the output minimums. We can hide and display parameters. If I don't want to see input P2, I can deselect it up here, and it is hidden in both the chart and the table. I can redisplay it by reselecting it, and can do the same for any parameter. We can change the parameter order by dragging parameters on the chart, and again note that the parameters are also reordered in the table. Then we can click the Reset Sorting button to revert back to the default order. We can also filter design points by parameter value. To do so, click on a Y-axis and then drag the cross that displays. The box that appears, also called a brush, is the filter. Numbers at the top and bottom indicate the upper and lower bounds. We can resize the brush and can also move it up and down on the axis. To remove a single brush, click its Y-axis. To remove all brushes, click Reset Brush. To find feasible design points, we can create filters to adjust the range of each parameter. Since we want to minimize board thickness, equivalent stress, and displacement, we'll create filters to hide the upper part of the parameter ranges. Design points with parameter values not falling within the defined ranges are hidden in both the chart and table. And now, because we want to maximize the inertial load, we'll create a filter to hide the lower part of the parameter range. Here, we wind up with one design point, DP11. Let's expand the range of P2 to include more points. Here, we've added DP5 and DP6. Of these 3 points, I'm most interested in DP5 and DP11, so I'll rename them in the table. I'll rename DP11 to Inertial Design, and I'll rename DP5 to Thickness Design. We can use the chart to discover how these new design points relate to the other design points. For example, we can reset the brush to view how they compare to the current design point. Now, to view one of my proposed designs, we just need to set one of the new design points as current and view the results as usual. Here, in the Design Points table, we'll set Thickness Design as current. Here is the equivalent stress result for the Thickness Design design point. Now, let's set our other design point as current. We can do that right here by selecting Inertial Design from the Design Point dropdown. This shows the equivalent stress result for the Inertial Design design point. We can view our results for displacement magnitude in the same way, by opening the result and setting different design points as current. This concludes our demonstration of using the parallel chart of the AIM Design Points dashboard.